Welcome to part 2 of week 9 of the ECE9013 course. In this part, we will be discussing 3 sorting algorithms, namely the monkey or Bogo sort algorithm, the bubble sort algorithm, and the selection sort algorithm. So, why do we need sorting algorithms in the first place? Basically, we mentioned that sometimes sorting, if we do it only once, can be helpful in more efficiently searching for elements. However, we would also want to be able to efficiently sort a list of entries. Accordingly, in this part, we will see some sorting methods, including one that is quite efficient. The first method is what we call the monkey sort or the Bogo sort. This is the simplest, however, it's considered to be the least efficient because it does not follow any clear mechanism, but rather depends on randomness. So, as an example, think about sorting a deck of cards. We throw them in the air, we pick them up, we check if they are sorted. If not, we repeat again. So, in more technical terms, we check while the sorted is not true, that is, that the list is still not sorted, we just shuffle the elements within the list. In the best case, we would need to check n times, which is for every element within the list. However, in the worst case, it is actually unbounded because you can randomly keep on shuffling the elements infinite number of times. Therefore, this is the least efficient sorting method. A second sorting algorithm is what we call the bubble sort. So with bubble sort, we compare consecutive elements and we swap them in case one is larger than the other. So we compare every 2 elements consecutive and we swap them to make the smaller first. We continue this until no more swaps have been made. So the largest unsorted element will always at the end after each pass. So at most we will have n passes. So this is actually the code for the bubble sort. So in every case, we check for these 2 elements. If the previous element is larger than the current element, we need to swap them. If not, we keep it as true. So the inner loop or the inner for loop is used to do the comparisons, and the outer loop is for doing multiple passes until there are no more swaps. This has an order of O(n) squared because we would need for every inner iteration or for every outer iteration, which probably needs at least n times, we would need to go through the n elements of the list. So this is more efficient than the Bogo sort, however, it's not the most efficient. A third well-known sorting algorithm is the selection sort. So in the first step, we extract the minimum element and we swap it with the element at index 0. In the next step, we check the minimum element except at index 0 and swap it with the element at index 1. So this would keep the left or upper portion of the list sorted. At the ith step, the first I elements in the list are sorted, and all other elements are bigger than the first I elements. So again, in this case, in every iteration of the outer loop, the inner iteration also would need to, on average, span the remainder of the list. So the outer loop would execute length of L minus 1 times, and the inner loop would execute length of L minus I times. So overall, the complexity of this sorting algorithm, again, is O of n squared. Thank you.